last night, Richard Somerville from Scripps. And I don't know whether you were there. Yes, both of you. It was a really very good lecture. After Bill does that, then Tom Bowman, who is going to come up, and Tom is going to talk about how do you make people care? How do you create campaigns that become movements? What kind of language you use, and so on. Bill Patzert is a research scientist at JPL. He's been there, how many years? Since 1983, since 1983.
27.
And he was at the Scripps Institution of Oceanography before that. His PhD and master's degrees are from the University of Hawaii. His bachelor's degree is from Purdue University. He not only is known as being an outstanding scientist, but you often see him on TV whenever anything happens, an El Nino or a La Nina. They always call Bill to be on TV, and he's been one of our partners here for a long time, and he's about to get a very important award. When do you get that award?
In 3 weeks.
In 3 weeks. You have to tell people about that. And yet, our other speaker I'm going to introduce now. We'll take a break after Bill, but Tom Bowman. Tom Bowman is the founder of Bowman Design. It's a wonderful exhibit design firm. It's located here in Long Beach. They've done all of our recent exhibits and are doing a number with us right now. But in addition to being an exhibit designer, Tom is one of the premier interpreters of global change, climate, and of energy science and green business strategies, and he's spending a lot of his time now on helping get across these important messages of climate change and what we need to do. And he is the lead author on a letter that will appear in tomorrow's Science magazine, again calling for, giving a wake-up call for us to do something about what we're doing to this planet. So, Dr. Patzert. And we have to put this on you. You
think I need it? Can everybody hear me?
Well, but it goes into the camera. And say, we want to record you for posterity. For prosperity. No. Okay.
Well, thank you very much, Jerry. It's nice to see so many familiar faces here. I know this is an extremely well-informed audience. All right. But, I'll give it to you again anyhow. Now, this course centers around the Gulf oil spill. It was one of the great environmental disaster events that ever happened in the United States or anywhere else. And then I'll get into what the implications of our fossil fuel addiction are in the long run as well as the short run. And I'll just give you the answer in case anybody falls asleep. The answers are two. Humans tend to have very short memories, all right? And the status quo, which is always the enemy of change and progress, moves very slowly, all right? Now, you all knew that, right? Okay, let's talk about the BP oil spill. On October 20th, what happened, they were trying to cap this well, and through negligence or hurrying, or what came out recently, the decision was it was a series of bad decisions, all right? They had this tremendous explosion, which eventually blew up the rig. But the thing about it, it was 1,500 feet below sea level, which makes it pretty unique. Now, there have been a lot of oil spills all over the planet. Anybody that drills for oil, whether it's in the coastal zone, the near shore, the deep water, or on land, the history of oil spills is long. 11 workers were killed, and then the thing was capped, fortunately, about 3 months later, right? And so what happened, there was about 5 million barrels of crude oil that spilled into the Gulf from depth coming up. So it was a pretty big event, a lot bigger than the Exxon Valdez and events we've seen elsewhere. Although these things happen everywhere. On every continent there is offshore drilling, whether it be in Asia, in Europe, North America, South America, Australia. So there's a lot of offshore drilling. Now, Let's talk about the Gulf of Mexico. The Gulf of Mexico produces 1/3 of the United States' oil production, all right? There are approximately 4,000 rigs and platforms, not all of them operational, all right? So it's a busy place, and that doesn't include what's off Venezuela and Mexico, all right? And it's a major industry in the Gulf states, all right? It employs an awful lot of people in Louisiana and Texas, Alabama, and Mississippi. You know, historically, they've been plagued with problems. You know, since 2001, I looked this up, there have been 858 fires or explosions on rigs in the Gulf of Mexico. Yeah? Not all of them were this big. So, in one way, it wasn't that unusual. Just the magnitude was unusual, all right? And of course, it was pretty spectacular. Even NASA got into it on May 23rd. If you see all the areas here in the Gulf that tend to be grayish or hazy, this is the main area of the spill. And this is the mouth of the Mississippi, coast of Louisiana, Alabama and Mississippi, going over into Florida. And so it was pretty big. Now the good news is that this thing did not get into the loop current or any other strong currents. So it was pretty confined to the northern Gulf, although it was big, all right? And of course, we saw all these iconic images that every day in the news and the newspapers, you know, the little turtles, the birds, all right? There was marine life destroyed, all right? But again, it was fortunate because it wasn't little turtles in the thousands, it was in the hundreds. And the same thing with the marine birds, all right? So this thing was big, but not as big as some other things we've seen. For instance, there was more marine life destroyed in the Exxon Valdez. Now, I'm not belittling, all right? But these images, you know, are pretty powerful. And, you know, it had a big impact on the American public and actually all over the world for a short time, all right? Now, some of this oil stays at the surface, but some of it sinks. And so there are actually deep sea corals there in the Gulf, northern Gulf of Mexico. And so some of this stuff, the oil sometimes becomes heavier and sinks. And so a lot of the bottom marine life was impacted by this oil. We really don't fully know what the impact of that was. All right, this I got from the LA Times. It's a little schematic here. Let's see, where's the zero? Yeah, here's the laser. But you can see, from the slick, some of it sinks, some of it disperses and is carried by the currents and the winds, all right? And as it disperses, it breaks up into smaller and smaller parts. Some of it goes to the bottom, some of it goes to mid-depth. The oil actually becomes lighter than the water, all right? And so we're still trying to find out what the extent of those large underwater plumes are. But the good news is about these oil spills is that they generally disperse and they biodegrade, mostly through bacteria actually, and evaporation. And so today, you know, actually visibly along the coastline of the Gulf and out in the middle of the Gulf, it's really hardly visible at this point. But who knows what the overall damage was. You know, they're back to fishing. And of course, there was a tremendous outrage about this, all right? You know, the Obama administration on May 30th, they instituted a 6-month moratorium on offshore deep water drilling, all right? And so this was about 10 days after the spill. And, you know, my reaction to that is they didn't know what else to do, okay? Because, you know, that was not going to re-engineer all those 4,000 rigs in the Gulf. And of course, saner minds prevail, all right? Is that after a while, the big thing became in the Gulf, a month, 2 months, 3 months later, was there a lot of people out of work, all right? There were fishermen, there were people on the oil rigs, all right? All the associated industries. And so, of course, by October 12th, they had lifted the moratorium. And so, more or less, the investigation is still going on. More or less, we're back to where we used to be, all right? Now, this is not that unusual. We've had huge oil spills. Actually, going back to 1911 in the San Joaquin Valley, we had a huge oil spill that they're still cleaning up from, all right? In Siberia, on the northern rivers of Siberia, they've had mammoth oil spills. In the North Sea, all right? In Southeast Asia and Indonesia, all right? Just about everywhere you drill for oil, you get spills. And so there's always been a lot of environmental damage from oil spills, all right? So what did we learn? Plus, it costs billions of dollars to clean it up. All those people out there with tissue papers and absorbent stuff, you know, and you know, that was a lot of money, which of course you paid for, because most of it was paid by the federal government or BP. Right? They say BP, but and it was big news for a while. But today, except for this class here, hardly anybody thinks about it very much. And actually, I checked the newspapers for the last week, and there wasn't anything about it, right? And so, right now, unfortunately, we're back to where we were, all right? We're heavy into our oil addiction, not only here in the United States, but everywhere else. Actually, in other places in the world, it's worse, you know? In China and India. All right, so, you know, that's my take on the oil spill, right? I'm not belittling it, I'm just telling you what happened. All right, the spill is over, so we're back to pumping CO2 like crazy into the atmosphere. And it's big oil, big coal, and big gas, the big three, all right? And the world's economies definitely would come to a standstill without them, all right? So the challenge, of course, is how do we wean ourselves off that when the third world has got exponential expanding industrial growth, and people still want to have at least 2 or 3 children, all right? Now we all know, and I'll talk about this a little bit, is when you add more CO2 to the atmosphere, what happens? It warms up, right? Don't be bashful now. I want everybody to jump in, right? And, of course, we all share the atmosphere. Doesn't make any difference whether the CO2 goes in China, India, or LA. Eventually, all that air, in 3 or 4 days, goes all the way around the planet. And so we all get to share it. All right. Okay, now, here's the first set of data I'd like to talk about. This is the monthly global temperature anomalies, that's departure from normal, over the last 130 years. Now, this is the one, you know, where all the climate gate scientists got so much static about it, right? And you see the 3 major sources of data, that was the Hadley Center in England, NASA, and NOAA, the National Weather Service. There is some difference between the two. Sometimes we have a steep increase, then you actually get a decline, stabilizes for a while, and it comes up again. But the bottom line here is that the average temperature of the planet, the surface of the planet, has increased about 1 degree centigrade, almost 2 degrees Fahrenheit over the last 130 years. And if you've heard about the hockey stick, where things were pretty level for a while, and then it all of a sudden the temperature started to dramatically increase, well, this is the hockey part of the stick, all right? But I've just given you this small part of it. Now, there's a lot of controversy about this. Is that in ClimateGate, you know, some people said that some of the scientists were shredding the data, they were cooking the data, all right? Or the dog ate my data, all right? And so climate scientists were really under attack by the conservative media, by the pundits, all right? So now the question, a lot of people, I get the question, you know, is global warming real? I don't know how many times I've heard that. Is global warming real? Okay, so you all know, anybody here think global warming is not real? Oh, this is not going to be much fun. There's always a couple. Oh, come on, somebody thinking.
My parents don't think it's real.
There you go. Yeah, yeah. And but you know, after tonight, you'll be able to convince them that it is. All right. So is it the real deal, you know? Is it the musing of idiot leftist scientists and Democrats like me, you know? And of course, most of you, you know? Now, the other thing, is it really happening now, or is it out there in the future, right? Is it going to change my world? You think it's going to change your world? Yeah. And, you know, but you know when? You know, maybe it's not going to change my world because I'm an old dude, you know? You know, maybe the kids and the grandkids, you know? And then, of course, since I'm an oceanographer, the important thing here is the role of the oceans. Now, you know, one way to deal with this is the bullies, you know, what I call them the bullies, all right? And we see them on talk TV, talk radio, all right? Conservative media, print, and otherwise. And let's get right down to it. They are bullies, all right? Now, you know, I was often asked, you know, would you like to go on and discuss this thing with Rush Limbaugh, all right? Yeah. And so I said, sure, bring the fat creep on, you know, I'll talk to him, you know. But of course, as soon as I said that, they knew I was just like him, so they wouldn't let me on. They thought I was going to be some wimpy scientist. But, you know, that's really not the right way to approach things. And we often approach things that way in this country, whether it's politics or science, you know. Poor Darwin, you know, just think how much he got bad. Galileo, you know. Poor Christopher Columbus, you know. All right, let's do a simple global warming 101. The greatest source of greenhouse gases, of course, as we said earlier, is coal, oil, and gas. And let's not forget, you know, some of the biological sources, things like corn ethanol and sugarcane ethanol. Those are big sources. And of course, the data is, one of my old buddies, a guy named Dave Keeling at Scripps, in the early 1950s, at the encouragement of a guy named Roger Revelle, who was really the father of all of this, he encouraged him to start taking detailed measurements of CO2 in the upper atmosphere from Mauna Loa in Hawaii. And when he started that, it was about 300 parts per million of CO2. And now it's about 390 parts. So that's a big increase. That's almost like a 30% increase in the last 60 years. Now, is that big, or is that just natural variability? You know, does it, you know, the things, we know things change. We have ice ages, right? Let's look at the CO2 record. Let's go back a 500 million years. And we can build a proxy of the CO2 record from things like ice sheets and ocean cores. And you can see the line here, what a wimpy laser, yeah? below 300 parts per thousand, it's been below for 500 million years. And then all of a sudden, it started rising, especially in the 20th century, later half of the 20th century. So CO2 has not been this high in 500 million years. You actually have to go back, you know. No, I'm sorry, yeah, 500 million, 500,000 years. And so that's pretty dramatic. You know? And, you know, of course, in between there, whoops. How do I go back? Here we go. These guys here are things like ice ages. All right. This is like when the North American continent, half the North American continent was covered by a couple miles of ice. And so those were pretty dramatic climate changes. Now, let's go back only 1,000 years. And let's look at how much carbon we put into the atmosphere in the last 1,000 years. And you can see that, you know, for, you know, from about the 1800 to 1,000 years back, it was very little. All right? Whatever CO2 we were putting in the atmosphere is the red part of the curve. All right? Now the red part of the curve, what is that? What happened before the Industrial Revolution? Agricultural Revolution, see? And so really, and that really started to accelerate in the 1800s. So in the 1800s, we had the Agricultural Revolution, we started clearing great forests to build great farms to feed the expanding population. The population of the Earth in 1800 was about 600 million. That's all, 600 million. Population of the United States today is 300 million. And then all of a sudden, in the 1900s, we got the Industrial Revolution. And then we really started cranking oil, gas, coal, and things really increased dramatically. But the red box here tells you that about 8 gigatons of carbon per year are from fossil fuel use, but about 1.5 gigatons is from land use. So 20% of the increase in CO2 is cutting down the forests, like in Brazil, in Indonesia. Right? And that's mostly for agriculture. Right? So it's a big part of global warming is land use. Now, how does global warming work? You know, for 500 million years there, we had a pretty nice balance. It was an imperfect balance, but it was a balance. We're a solar heated planet. The amount of heat coming in was essentially captured in the atmosphere. Some of it got through, and then it was radiated back. And the balance was pretty even. And so the climate of the planet, aside from the ice ages, which is caused from something else, stayed pretty steady. Then we started adding all these greenhouse gases, CO2, methane, other greenhouse gases. So what happened? Now all of a sudden the atmosphere is getting hotter because these have a very high heat capacity, CO2. That's why we call them the greenhouse gases. They absorb and they keep the heat. They also have a very long residence time. So if you put CO2 in the atmosphere, it's not going away for 50, 60, 70 years. Even if you stop driving all the cars and turn off all the power plants, it would still be there. And so what happened is that the planet was pretty happy, but then the Earth started warming up, as we saw in the first curve I showed you, which has been about 1 degree centigrade, 2 degrees Fahrenheit over the last 130 years. Now, what happens if we keep up this imbalance? All right. Is that we keep adding more and more these greenhouse gases. The atmosphere is going to heat up more, and the planet's going to heat up more. So that's no problem, because what we're going to do is we're going to have cap and trade. All right, we're all going to switch to solar, right? And so all of a sudden we're going to restore the balance. And so after a while, it might be a warmer planet, but the planet won't warm up anymore, right? So the balance can be restored, but it's never going to be the way it was, all right? So the future definitely ain't what it used to be. You're living in a warmer world now, and it's going to get even warmer, no matter what you do. You can interrupt me anytime you want. Okay. All right, now climate change in the oceans. Now what makes the Earth different than most of the other planets in the solar system is that when you look back on it, it looks like the blue marble. And it has 70% oceans. So the water makes all the difference. Our nearest neighbors, like Venus and Mars can be extremely cold, all right? Extreme temperature fluctuation. Whereas Venus, which has a very heavy atmosphere, is like the greenhouse thing gone crazy. And so neither one of them support life. I shouldn't say that coming from JPL, but you know. Trust me, there's no life there. All right. So, you know, one of my great mentors, who was Arthur Clarke, he said, you know, how inappropriate to call this planet Earth, because it's clearly ocean, and the oceans are the thing that makes the difference. So climate change is what the oceans do, because most of that heat is being taken up in the oceans. So where does the heat go? So the amount of heat absorbed by, you know, different parts of the Earth system, say in the last 40 years is when we've been heating up, you can see that most of that is going into the oceans, all right? Not the atmosphere or the continents or even the ice, because the ice has a very high albedo. And you know, this is true just from living in California. It heats up during the day, right? And then it cools off at night, right? because the land and the atmosphere have almost no moisture. And so there's nothing to capture the heat. Whereas the oceans are extremely stable. They don't change very much at all, either with the seasons or slowly warming. So the key is the oceans. But a lot of people say, you know, okay, that's all good and everything, but, you know, people are literal. They want to see global warming, you know. Anybody seen any global warming? Well, you actually have, you know. Right. Now, what we've done here is we've taken the tide gauges, like they have one here in Long Beach, going back about 130 years, and we've added a satellite record to it, and we've averaged it all over the world. So what you're looking at here, going back 130 years or so, is the average rise in sea level over the last 130 years. Now, why should the sea level rise? What happens when you warm water? It expands, right? And what happens when you melt glaciers?
Well, if they're on the land, they're going to add water to the fresh water to the ocean.
Exactly, to the ocean, right? So that's what's happening here, okay? Now let's look at it. You know, so that's been about 8 inches all over the planet. It's been 8 inches here right at the coast, right here at the Long Beach Aquarium in the last 130 years. Now, if we look at the early part of the record, the first 40 years or so, it was about 1 millimeter per year. I just eyeballed this. And then all of a sudden, from 1920s to about the 1980s, it was about 2 millimeters per year. All right. And now recently, it's about 3 millimeters per year. So it's not linear. It's actually going exponential. So it's speeding up. And it should speed up. All right. Let's just look at Southern California. In 1950, there were only 4 million people here. Now there's over 20 million. That's amazing growth, you know. The only country that had growth that big was China during that same period, and some African republics. So that's a lot of people using a lot of fossil fuel. Now, just to show you that it's true, the black curve is San Diego, and you can see there's in San Diego. There's your 8 inches, and then the other one is Long Beach, right here, the red one. But that's only 4 inches. Why is that? Why is Long Beach only 4 inches in San Diego?
The land is rising.
Here, see, yeah, the Palos Verdes Peninsula is actually a compression feature. And so the land is actually rising. So that's the good news for Jerry and the aquarium, all right? Is that, you know, you're not quite keeping up with sea level rise, but you're doing better than San Diego or San Francisco. Yeah, a good example of this, of that 8 inches, is if you've ever been to Broad Beach, very contentious, you know. All the rich people live there, not us, you know. Spielberg and all those guys, they all live in Broad Beach. And it used to be famous because it was actually a pretty wide beach with sand dunes. But because of the sea level rise, and then the second thing they did, which was really stupid, is they built all these seawalls. They had to build their houses right up to the oceans, and that actually accelerated the decrease in, or the disappearance of the beaches. All right, and so if you go to Broad Beach today, you know, it's pretty creepy. You know, it's all sandbagged and cemented. All right, but this is a preview of coming attractions. In actual fact, you have disappearing beaches in Southern California. We've dammed all the great rivers, which are the source of gravel and sand, which essentially revitalized the beaches every spring and winter. All right. And so one of the impacts that you've already seen, although it's been subtle, is your beaches are smaller. You know? Now, what's the estimate? I said 8 inches in the last century. People have made a whole series of estimates on what it should be in the new century, as the population is just exploding and the third world is struggling to be the second world. Or whatever they are. And the estimates run anywhere from 2.5 feet to more than 6 feet. And that's really dramatic, all right? And more or less, no matter what we do, that's guaranteed, you know? So Jerry, start building your dike, yeah? LA Harbor and the aquarium are going to be underwater in 2080. But, you know, and of course, low-lying areas, let's get back, of course, to the Gulf. All these low-lying areas around New Orleans, Mississippi, Louisiana, it's going to be pretty serious, as well as a lot of South Florida. And then this is, you know, a lot of places in Southeast Asia. And so, you know, this is serious business. Because, yes,
So that means that most of our islands are going to be gone.
low-lying islands. Low-lying islands. Some of them already are. They're starting to disappear in the Western Pacific. No, they've come and gone anyhow, because in the great ice ages, we've actually seen rises of sea level of over 300 feet. All right? But that happened over thousands of years. What I'm talking about is 50 to 100 years. It's a big difference. And back in the good old days, there were only a couple of 100 million people on the Earth. And we're headed for 10 billion. The other thing is that like 75% of the world's population lives within about 30 miles of the coast. So we're coast dwellers on this planet. Yes?
This has happened, these calculations really quickly, haven't they? And I'm thinking, like, I just bumped into Walter Monk last Saturday. Would love to remember to ask him, but
Yeah.
I remember the one really amazing lecture I ever had the honor of seeing that he gave was 2003. It was standing room only. He was talking about the latest calcs and sea level rise. And it was down in San Diego, coastal zone something. And he was saying 12 inches for the next, or 12 centimeters for the next century. Has it been that quick that there's been these amazing
Well,
adjustments?
12 centimeters would be 6 inches, and we had more than that in the last century.
Well, that's what I'm wondering. So,
Yeah.
I mean,
He's
so
wrong.
there are calculations in that range, weren't there, just a few years ago?
No, maybe Walters, but, you know, the people that are doing the calculations on how much, I'll show you in a minute. Most of it is actually loss in the ice sheets in the terrestrial glaciers.
Well, I guess I'm asking,
Not heating.
I guess I'm asking is when did the alarm bells really go off?
Well, this is, you know, that range right there has been done about 10 different ways, right? And the most conservative one they get is 2.5 feet. Right?
Now. So
Yeah.
well,
Yeah, and I don't know what Walter gave is, but I'll show you here in a minute what's happening on the ice sheets. Right? Now here's the Arctic sea ice. And this is pretty recent. This is 1979. So you know how it goes. The Arctic freezes over in the wintertime, and then in the spring and late summer, it melts back. And this is what the minimum of ice cover looked like in the Arctic Sea in 1979. All right. Now, 30 years later, this is what it looks like. That's a dramatic difference. Look at that. How dramatic is it? That's just huge. Yeah. All right, this is how much it is. So there's the extent in millions of square kilometers, and you can see the number up here is 8, and the number down here is 4. So over the last 30 years, the area has decreased by 50%. Right? But that's not even the whole story. Scientists are spending a lot of time up there now. And what's the thickness of the Arctic sea ice during the winter? How thick is it, you think? It's about 2 meters. It's about 6 feet. That's what it is out there on the North Pole, where Santa lives. All right? But over the last 30 years, it's now 1 meter. So if the area has decreased by 50% and it's thinned by 50%, the volume is 25% of what it used to be. That's huge. All right? And of course, there are all kinds of climate feedbacks because now we no longer have an Arctic covered by ice, which has a very high albedo, which will radiate back energy. Now we've got a lot of open ocean. And water and heat, you know, it's like, you know, I wish my marriage had been that good. Those two things are just wedded together, you know. It's the ocean just sucks it up. Now, where people live, you know, not that many people up in the Arctic. But let's look at the Himalayas. It's a great ice sheet with many, many glaciers. And for many centuries, you know, the winter storms would feed the snowpack and build the glaciers. and then in the spring they would melt. And they feed most of the great rivers of the Central Asia, China, and Southeast Asia, like the Mekong, Brahmaputra, the Yellow River. All right. But there's been a dramatic decrease or melt back in the great glaciers in the Himalaya. Right? It's been about 2 to 3 meters per year. So in other words, they're losing more than they're gaining. And that's a huge thing. 50% of the world's population is dependent on those rivers, those great rivers that come out of the Himalayas. They're already feeling. And on top of that, the Chinese are building dams, all right, and saving the water for themselves, so it doesn't, a lot of it doesn't get to Vietnam and Cambodia anymore. So it's political too. Now, Greenland is another place. You hear a lot about Greenland. We have satellites that measure the gravity field over and it can tell you how much mass there is on the Greenland continent and how much of that is changing. Well, it's changing dramatically. The great ice sheet is melting. Now, this is one of the great glaciers here in Greenland. Now, up here this is the ice sheet. And this is one of the great glaciers that feed off the ice sheet. Now, notice this. You see the ring around the bathtub there? That's 300 feet change in approximately 30 years. That's a tremendous decrease in the glacier, right? And this just shows you at the front of the glacier, all right? This is 2001, 2003, 2004. And we see this with many of the great glaciers, not only on the ice sheets, not only in Greenland, but also in Antarctica, as well as a lot of the terrestrial glaciers, for instance, in Alaska. Anybody remember Glacier National Park? Yeah, I call it the Ex-Glacier National Park. Right. Definitely save those little postcards, because it's never going to look like that again. Right. And so, we're already seeing it. That's my point, the guy with the head in the sand. It's warming, and we're seeing a lot of impacts already. All right. So here's my 10 key indicators of warming climate. Higher temperatures over the land, which I showed you. Higher temperatures over the ocean. The ocean is warmer. If you actually look at 100 years of sea surface temperature off Long Beach, it's a degree warmer than it used to be. Not this past winter. It was pretty cold. And the oceanic heat content, that's how much heat has been absorbed in the upper layer of the ocean. Say the upper 1,000 meters or 500 meters. It's warmer. All right. Now, near surface temperatures, that means like in LA, if you go outside or your backyard and you keep a temperature record, essentially in the troposphere where all the weather is, that's warmer too. And it should be, because that's where all the greenhouse gases are accumulated. We're seeing higher humidities in the atmosphere, all right? Higher sea surface temperatures, not only the heat content, but the surface of the ocean, all right? I showed you higher sea levels, less sea ice, less snow cover in many places, especially in the Sierras. There's a lot less snow cover in the Sierras. Now, why do we lose snow cover in the Sierras or in the Rockies? That's right, that's our water supply. Our winter snowstorm, snowpack, is our spring runoff, which is our summer water supply. Like in Colorado or the Sacramento or the San Joaquin River, which we steal all the water, remember the great aqueducts? That's a different lecture, all right? And the shrinking glaciers. So there's 10 for you, all right? 10, and the evidence is pretty indisputable. Now, of course, a lot of the skeptics will say, well, that's just natural climate variability. But this is definitely not natural climate variability. This is not tens of thousands of years or 100,000 years. This is 30 or 40 years. So we're living in a warming and a melting world. As far as I'm concerned, there's no doubt about it. And the warming and the melting are pretty important. Most people just talk about warming, but what's really going to impact us in many ways is the melting part. Because one of the critical problems in the new century is going to be water. That's really where the crisis will hit. Now, I just put this up here for you. I didn't calculate it for you. But sea level rise, many people think it's just the ocean is warmer, it expands. But actually, we've calculated this pretty carefully. And about 75% of the sea level rise is from melting. Somebody said that earlier, that young lady right there. Now, here's my thing, of course, all right? Now, like I said, 200 years ago, there were only 500 million of us on the planet. All right, 1,000 years ago, there were less, about 300 million. And now we're pushing 7 billion. Now, that's an interesting curve. Now, look at that curve, you know. I could have changed this, the CO2 curve and the population curve, and you wouldn't have known the difference, all right? So it was pretty constant here, 280 parts per billion, and now all of a sudden we're about 390. Okay. Now, I love to play with data. Now, wouldn't it be interesting, instead, and let's just take the time out of it, let's plot population versus CO2. Okay. I don't know how many of you are scientists or have statistics, but you can calculate a correlation coefficient. It's called an R-squared. Right? And of all the data sets I've ever run on anything, I've never had an R-squared at 0.97. That's the highest correlation you'll ever see in a science paper. All right? So it's the population, dummy, you know, and the Industrial Revolution and the Agricultural Revolution, which of course they all go together. You know, the population couldn't have expanded without the Agricultural Revolution or the Industrial Revolution. All right. So here's my solution, okay? Which of course nobody seems to be listening to me. All right. I tried to talk to former Cardinal Mahoney about this. All right. The way we can really ease global warming is by taming, you know, global population. Plus, there'd be immense benefits in many other areas too. For instance, like equality for women and things like that, better education for kids. But, you know, just keep that in the back of your mind, all right? Because that, in the end, that's going to be the key. Now, so Al, my buddy Al, right? Which, you know, the pundits and the right-winger just love to shoot at, right? Let's get right down to it, right? You know, his movie might not have been perfect, you know, but he's right. Global warming is real, you know, it's the real deal, and it's definitely guaranteed. Right. Now, of course, some people say, right, that, well, you know, Galileo had a theory, Darwin had a theory, you know, Einstein had a theory, you know, and, you know, he also, you know, the moon landing was a fake. You know, it was, by the way, we did it in Burbank. No. All right. Evolution is bunk, right? And global warming is a hoax. So, you know, they're just a bunch of theories. But that's not true, you know. I hope everybody's at ease that the world is round and evolution is real, right? Yeah. And Einstein was probably right, and doesn't equal MC squared, yeah. All right. And so, you know, that's one way that people argue it, all right? And it's just a way to diffuse it and delay it, all right? Because, you know, we got to keep using that oil and using that coal, you know? And if you actually look at the websites and the people that take these kinds of attitudes, almost invariably, they're all funded by the oil companies. Let's get right down to it, all right? And I don't understand it because, you know, we're going to be using oil and coal and gas for the next century, no matter what. Let me say that again. We're going to be using it to the max, no matter what. The only issue is how much we pay for it, all right? Now, if we greened ourselves up a little bit with solar, all right, population control, geothermal, all right, wind, all right, then, you know, instead of getting head-to-head with a hard ball, we get hit in the head with a wiffle ball. But oil is going to be with us. We couldn't build that stuff fast enough. It would be impossible, you know, no matter how good the economy was. Now, Tom will tell you different, but yeah. Now, here's another thing I'd like to remind everybody of. It's not just global warming. You know, it's what I call global warming versus local warming, because most of us live here locally, right? So what's happening locally? That's what I call the extreme makeover. Now, we talk about that the planet might increase 4 or 5 degrees in the next century. Now, let's look at the Los Angeles downtown temperature record. What's happening? Come on. Somebody step up. Say it. LA's heating up. How much? It's almost 4 or 5 degrees in the last 130 years. And Sacramento is the same, San Francisco is the same, the Inland Empire is the same, Orange County is the same, San Diego. So, and Tokyo is even more. It's like 12 degrees. All right? So, but is that global warming? What is that? All right? And, you know, they talk about in global warming, we're going to have longer and more frequent heat waves. Well, this is the number of heat waves, which you take 3 consecutive days above 95 degrees downtown LA. All right? And we'll call that a heat wave. And so you can see at the beginning of the century here, 1905, you know, we get a couple of 3-day heat waves, occasionally a 4-day heat wave. And then they started to increase more as we got into the 50s, 60s. Now we get an awful lot of 3, 4, or 5. And we also often get 2-week heat waves. You know, this is pretty extreme, especially the farther inland you get, and in the San Joaquin Valley. You know, not only is it serious, it's deadly. All right. Now, my students and I did all 330 stations for the state of California since 1950. It's one of the good data that most places starts. San Joaquin Valley, all right, out in the desert, the coastal zones. And you can see here, since 1950, everybody's warming up. You know, that's not necessarily global warming. Right? That's what I call land use changes. For instance, the San Joaquin Valley, which is about 1/3 of the state of California, the average rainfall there is about 5 to 6 inches a year. But as soon as we put in the California Aqueduct, you know, that thing that goes next to the 5 when you drive to San Francisco, that's 40% of our water supply, by the way. Now it's irrigated from north to south and east to west. And so instead of being a desert, if you went to the San Joaquin Valley in 1960, you wouldn't see any trees at all. I mean, it was a desert. All right? But now it's irrigated from north to south, east to west. And so when you put a lot of water on the surface, what happens? During the day, it heats up, and all that moisture at the surface retains the heat. And so the nights are warm. You see the same thing in LA. You know what LA looks like without sprinklers? All right? There's like one tree every 3 or 4 blocks, if you look at the old pictures, all right? So you got to remember, all these trees you see around here, not too many in Long Beach. But where I live, there's a lot of trees, all right? If you turned off the sprinklers, right, you'd have about 300 million dead trees in LA. So land use is a big thing aside from global warming. So this is serious. It's serious business. You know, they actually post signs now. All right. And when we have long heat waves, especially, you know, for the elderly and kids and pets. All right. So you've already seen a preview of coming attractions of what it's going to be like with global warming. All right. And most, of course, it'll be worse in the summer rather than in the winter. All right. So part of it is just us. There's just so many of us. You know? And we've done an extreme makeover. I always get a big kick out of when I have to speak to the Sierra Club, and everybody wants to keep things natural, you know? And I tell them, you know, California hasn't been natural since 1848, you know, since the gold rush, right? We definitely did an extreme makeover on the state of California. There's hardly anything here that's natural anymore. Certainly not the vegetation. You know? And so, it's not just global warming. Right? It's, you know, how we build our cities, how much lawn we have. Right? So this is I dug this one up. This is from Mount Wilson in 1902. This is what LA looked like. All right? And this is LA today. You know, and we've all seen it flying into LAX at night or during the day. All right? So the bottom line, it is us. Okay? It's not just the oil industry. You know, there's a lot of us, right? And we have done an extreme makeover not only on LA and California. as I showed you, we've done an extreme makeover on the planet with all the deforestation we've done, air quality, the chemical composition of the atmosphere. So we're never going back to the future, and I always like this one. I think I got this from the San Diego Union. This is going back to 1950. In about 50 years, the population of the United States doubled. Population of California increased by a factor of 4. And the population of San Diego County, which also includes the Inland Empire, increased by a factor of 6. It's amazing, huh? Like I said earlier, the only other countries that's done that are like China, before they had the one-child policy. So they went from, at the time of the revolution in 1948, they went from 300 million people to 1.5 billion today, which is about equivalent to what California did. So, needless to say, the environmental stresses are really increasing, all right? All right. Now, one of my favorite prophets, Yogi Berra, and he said, it's pretty tough to make predictions, especially about the future. But I think I could venture a few predictions for you. All right. It's going to be warming. All right. It's going to be melting. It's going to be more crowded. All right. And the impacts locally are going to be even worse than what the scientists said, because climate change is local. All right. You've already seen it. LA is 5 degrees warmer. We have more heat waves. We're headed in for a water crisis. All right? The Colorado has got 20% decrease over the last 100 years. All right? That's 30% of our water supply. All right? We want to save the smelt. And so pretty soon we're going to have to make some decisions like, do we want to save the smelt or have our lawns? All right? That's really what it's going to come down to. Because 70% of the water you use is in your yard. So the real enemy here is the status quo. Nobody wants to change, Look at all the, I got caught on the 710 tonight. There were 2 big accidents, one really bad one. So it took me 2.5 hours to get there, along with I don't know how many thousand other people. So you can imagine the CO2 we put to the atmosphere tonight? I feel guilty. I came down here just to talk to you people. I did 2.5 hours of CO2 on my muscle car. Give me the environmental message. What's with that?
You're a sad person.
Okay. So, there's been a White House report lately on man-made climate change impacts in the U.S. And one of the things they talked about was, that's not going to show up. But more intense and frequent heat waves. This is the only one that didn't work now. Rising sea level, and essentially all the things that I listed, all right? And include one of the big things they talked about was increasing drought in the American Southwest, all right? Which is really, it's at our doorstep, the water crisis. All right? So, this is the point where my mom says, Jesus, the guy's the Grim Reaper, It's the end of the world, No, it's not the end of the world, The world is pretty resilient, all right? All right? No. My point here is that we got a couple of choices here, but no matter what we do, we're going to adapt to a different Earth in the same way that we already have. All right? All right? Like I said, the oil spill wasn't in the newspaper all last week. So we all adapted to it, all right? We're studying it now. But they're back to deep water drilling everywhere, all right? And, half the railroad cars in the United States are carrying coal from Wyoming and Montana to the Midwest and the East Coast. And so it's definitely going to be around for a while, all right? But the fundamental thing that we have to really get a grip on here is that how do we slowly cut back our fossil fuel addiction? Now, hopefully Tom will talk a little bit about this evening, all right? That's really the big challenge, all right? Because otherwise, no matter what, you're going to be using oil, and coal and gas, no matter what. All right? Now the question is, like I said earlier, how much you pay for it. All right? Because will there be something competitive? You know, will there be solar? Will there be geothermal? Will there be wind? All right. Will we cut back? Will there be electric cars? All right. Will we just use less? All right. That's really the challenge. But we're never going back to the way it used to be. You know, that's like when you lecture your kids. When I lecture my son, you know, I tell them, well, when I was your age, we walked, we walked to school every day barefoot through 6 feet of snow, and studied for 10 hours every night, and I can see his eyes glaze over. But it's never going back that way. Okay, so that's it. I think I've taken just about an hour, right, Jerry?
That's good.
Told you more than I know, and that's one man's view. Thank you.
All right, well. We'll take a couple of questions and we're going to take a short break and Tom will come. My couple of comments from me. As I look at it, if population is the driver, if two of the things that we do are causing all these problems. The kinds and amounts of energy we use and the kinds of food we eat and the way we grow and harvest that food. And while at the end, the Earth isn't going to end. It's been around for 4.5 billion years, and life's been around for 3 billion. I guess I'm more pessimistic than you that unless we change the ways that we live, I can see by the end of this century that the kinds of life that we see now will be in jeopardy, including humans. You can only adapt so much, and the thing is that we lose ecosystem services, and without the ecosystem services, we're toast.
Well, that really, I could go on for another couple of hours on the collapse of ecosystems, and we're living really in the great age of extinction, not of humans, but of other species. Overfishing, a lot of small species that you don't see on the World Wildlife Calendar, all right? And so, never before, this is like, we all know what happened to the dinosaurs, all right? But now it's happening today, at all levels of all ecosystems, both on the land and in the ocean. And so, we're definitely crushing the Earth and changing the ecosystems. And, hardly anybody seems to notice.
So let's take a couple of questions from other people before we take a break. Who has a, put them on the spot, somebody. Go ahead.
I always hear that people saying California's going to be underwater. Is that true?
Every place except the Aquarium.
Well, in the next century, say the sea level rises 2 to 3 feet. And of course it won't, the good thing about Southern California, most of it is bluffs. It's not low-lying. Except, of course, for the Port of LA and Jerry's Aquarium. Bad choice, Jerry. Should put it on a cliff.
Now, we're counting on it. There are places like these ports. The investment is so large, we will protect these areas.
Yeah, that's right.
And we're in the lee of that, so we're on. With sea level, someone said, why didn't they sound the alarm? I don't think we've really sounded the alarm yet. The IPCC in the 2007 report, they buried it as I can't remember the exact language, but it predicted that by 2100, sea level rise would probably, and I'm going to convert it to British engineering units, about 2 feet. And then there was a footnote, and it said we are not taking into account any contributions from Greenland or Antarctica. And the trouble is, people quote that report, they never refer to the footnote, and we see these big changes in both of them.
Yeah, well, a good example, that's a really good question, because let me give you an example, is New Orleans, my least favorite city, is that, we had a big hurricane there, and so the whole thing, went underwater, the Corps of Engineers didn't do their job, probably shouldn't have built it there in the first place. But the problem in New Orleans was, and this comes into what I said, global warming versus local land use. The subsidence in New Orleans from pumping gas, water, and oil out from below southern Louisiana was 3 feet in the past century. And then you put the 8 inches of
global warming sea level rise on top of it. So the biggest impact was really pumping everything out from beneath the city, all right?
Over that time scale, yes, but over tens of millions of years, the Gulf has been sinking. That's why we have oil.
Yeah, but the 3 feet was dramatic, and that was mostly subsidence due to take. Venice is the same way, by the way. That's why they, you know, drain all the water from the aquifer underneath it, so it sinks.
So we do have a problem though, and Tom is going to tell us how we can avoid that problem and all be prosperous. Let's take a 5-minute
And just
break.
say one last story.
Okay.
You know, I gave a talk to the Sierra Club the other day, and they wanted me to talk about Mayor Villaraigosa's Million Tree Initiative. Sounds good, right? Plant 1 million trees, you know? So all the kids in the, you know, the underclass in South Central can have trees, all right? But you know how many gallons a day a tree takes? It's 50 gallons a day, all right? So if you plant 1 million trees, that's 50 million gallons a day. All right? Can you imagine at a time when we're talking about drought and they're cutting back our allocation from the Bay Delta and Colorado? So, you know, things are, you know, sometimes there are unintended consequences of things that sound good.
Plus the amount of CO2.
Now, of course, they were horrified, the Sierra Club. And the tree people, you know, I was lucky I got out of there alive.
You know, even if they were no talent and they didn't use much water, the amount of CO2 they would remove is so small. We had kids here yesterday from Santa Monica High School. These are really smart kids, nice kids. And they're doing a project on it is getting rid of single-use plastic bags, which is a good thing. I said, why are you doing it? And the answer was so that we will reduce greenhouse gas emissions because everybody knows plastic bags come from oil. And I said, yes, and you know, though, that all plastics of all kinds account for about 2% of all the oil that we use worldwide, and the amount that we use for plastic bags is infinitesimal. So you have a better reason. Somehow we have to put these things into context and perspective so we make the right kinds of decisions.
Now, of course, this is the other one. They always say, you know, I want everybody to read Tom Friedman's book. You can get it at Costco, you know, which is probably producing tremendous amounts of greenhouse gas. Yeah. Then this is my last one. Everybody wants to know what's going to happen with the winter. Even though it's going to rain like hell this weekend, which is going to be sweet, actually.
Ruin our attendance.
But this is the histogram or frequency diagram of rainfall in LA for 130 years. And you notice it's bimodal. The average is 15. So, you know, the average really doesn't happen that often. I always say normal or average is, normal is a cycle on a washing machine, you know? So it's either wet or it's dry, all right? Now, we're in a big La Nina right now. And so what I've plotted here is the amount of rainfall during the La Nina years. All right? And so you notice that essentially there's like an 82 to 85% probability that you get less than normal rainfall. All right? And actually, it's also bimodal, but I'm taking up too much time here. So this is my satellite. So we started off the beginning of the year in January with an El Nino, where you get very, very warm water wrapping around the equator. And now it's very, very cool water or lower sea level. And this is a very strong La Nina, really strong, all right? And often in a La Nina, you get early rainfall, November and December, but the months that we really want our rainfall or our snowpack are January, February, and March. And so my forecast, in spite it's going to rain this weekend, which is normal for a La Nina, all right, is that it'll get pretty puny after the new year. So that's it.
Bill, thank you. Take a quick break from that. This was the first spill of any size that we have actually burned oil in the ocean. And the amount of oil that was burned in the Gulf exceeded the total Exxon Valdez bill. That's pretty amazing.
But I think the environmental impact from the Exxon Valdez will turn out to be bigger.
I would agree with that.
Yeah.
That we could talk about that sometime, but Tom, he gets very nasty and you take too much of that.
So
bill depress everybody?
But you're gonna lead us out of the wilderness.
I'm gonna make it worse first. I am not a scientist, which should be a relief to all of us. I am a communication guy. I'm an exhibit designer. I work on brand campaigns, I work on education campaigns. And communication is a practice. It's as much, it's part science, it's part psychology, part sociology research, it's part art, it's part writing, it's part inspiration, it's part statistics, it's a bunch of things mixed together. And Jerry mentioned at the beginning, he would like you to talk about how you develop communication campaigns that make people care about issues like this. And I'm going to sort of walk through a general, one way of looking at it. The reason I say there are so many aspects to communication is that you can look at it from so many different ways that you can't really consolidate it into an hour. So, but I'm going to give you one way that I've come across recently that's actually really very powerful and handy. But I'm going to start with some framework, and that is sort of the aspiration that our country and other countries of the world have signed on to. And this is how you don't do good communication. This is from a document called the UN Framework Convention on Climate Change that was signed by the international community and the United States back in 1992. And aside from all the gobbledygook at the beginning, it says that the parties to the convention commit themselves to stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. In other words, does anybody here speak English? It means we're not going to change the climate because of the things we do to a point at which it's dangerous. The problem is there isn't a real strong agreement about what constitutes dangerous. And this is what's happened since then. This is the Keeling curve of CO2 in the atmosphere as the background that Bill talked about. And this is just a series of historical events along the way. So Jim Hansen first told Congress in 1988, 1989, that we could discern a human footprint on, or fingerprint on the change in the climate. The first IPCC report from the UN came out around late 1980s, 1990, and the UN Framework Convention is here in 1990 or 1992, or excuse me, here in 1992. Kyoto Protocol was negotiated in 97. There have been 4 IPCC reports, and you see the curve continuing to rise upward. And that's a statement about our collective failure to come to grips with this problem. So there's a terrific new book out by 2 guys who write books about communication campaigns. The book is called Switch. Smart communication authors use one-word titles. Their names are Heath and Heath. I think it's Dan Heath and Chip Heath. And they talk about, the subtitle of the book is How to Create Change When Change is Hard. And what they really focus on, primarily in the book, is a single insight, which is that if you want people to change, you have to address their thinking, their emotions, and you have to clear the pathway. You have to make change possible in their environment. In other words, public health campaigns often have said, you know, it's you should walk to work, you should ride the bus to work. If there is no bus, if work is too far away to walk, you make people upset, and there's nothing they can do about it. So you have to attend to the environment as well. And so I want to sort of present the idea that we can respond to climate change effectively in the context of looking at the 3 aspects. The rider, the analogy they use is there's an elephant on a path with a rider. The rider is the mind. It's the part that sets the direction, has the intention. But the mind wears out, right? Have you ever just tried to diet or tried to exercise when you weren't into it, right? Willpower alone will only take you so far because, like any muscle, effectively, willpower wears out and you get tired. Well, the willpower comes from the elephant, which is really your emotions. It's the things that drive your motivation. So if you want to move the elephant down a path, the mind has to know where you want it to go, and the emotions have to be involved so you'll stay committed to going there. But the last thing is you have to have a path to walk on. If there are fallen logs in the path, there's walls in your path, If you're on the 710 and there are 2 horrible accidents, you're just not going to get there, right? So all 3 are important. So let's start looking at it. And one of the most interesting facts, I guess, about human cognition is that we simplify. Humans inherently simplify. So if you want to develop a good communication campaign, part of our challenge is to help people simplify in appropriate ways, because they're going to do it anyway. And if they do it inappropriately, it's going to be a problem. Scientists don't do that. This is what the IPCC presents to the world. You know, the world of any academic field, and the sciences are no different, become increasingly narrow and specialized. And so when you become highly trained, you learn to speak to your peers. You don't learn to speak in public, right? So, and I love to have fun with this because it's just a little bit of a joke. This is what's causing climate change according to the IPCC. This is where we're headed. This is what it's going to do to us. Here's another example of what it's going to do to us. Here's another example of what it's going to do to us. And here's how we get out of that. And you know, as a graphic designer, if your footnotes are the same size as your graphic, you have to go back to the studio. We need to simplify this information because these graphs I just showed you tell us an awful lot about what matters. So here's a shot at it. Right? This is very simple. This is the temperature of the Earth before the Industrial Revolution, and this red bar goes to where we are today. These dashed, this is about 0.8 of a degree. This other half a degree or so is already baked in the cake. This is the warming that's going to happen anyway because we warmed the ocean and we have CO2 in the atmosphere that's going to stick around. So we can't really avoid that. And if we were to not do anything about this over the long term, which is probably centuries, there's a lot more warming yet to come too. So, interestingly, the nations of the world have made sort of an aspirational judgment. It's not a science judgment, it's a political judgment, it's a value judgment, that letting the world warm beyond 2 degrees Celsius above the pre-industrial temperature would be crossing the line into what's dangerous. And so the European Union adopted it a few years ago as a policy. The group of 8 nations about a year and a half ago, 2 years ago, adopted it. And it's been adopted by about 200 nations. The United States has said that we're part of this too. So if we want 2 degrees to be our limit, we don't have very much room left. But if you want to make a decision about a judgment call about what you're willing to live with and not willing to live with, you sort of have to understand the consequences along the way. And this range from 1 degree to 6 degrees or so is sort of the boundaries, roughly the boundaries of what is likely to happen in this century. Bill Ray, yell at me if I get this wrong. But this is sort of taken from the IPCC report, and the probability isn't that it's most likely going to be at the top end or the bottom end. It's most likely going to be in the middle. Well, I went through the report and pulled out a few of the impacts that have very, very high confidence levels associated with them. And according to, well, this is interesting. This went from a keynote to a PowerPoint and everything moved. So it's a little scrambled. But already we're seeing significant increase in extinctions. Corals are bleaching. There are a lot more wildfires. There's more drought. There's more storm damage along the coastlines. Increasing mortality from heat waves and drought and floods and kinds of extreme weather events. And the IPCC estimates that there are already about 25 million climate refugees in the world. That's now. If we let the world warm to 2 degrees, this border between what we don't really want to see and what would really be dangerous, it's not a picnic. The estimate is anywhere from roughly 10 to 30% of all known species would be committed to going extinct. All corals would be bleached. Food production starts to drop in the tropics. It increases in some other places, but starts dropping in the tropics. Malnutrition, diarrheal diseases, respiratory diseases are on the rise. And up to 1.7 billion more people face water stress every year. So this aspirational goal of 2 degrees isn't exactly a good time. But if we let the world warm to 4 degrees, corals are extinct. Half of nature reserves in the world fail in their missions to preserve species. 30% of coastal wetlands are lost. These are, of course, estimates. These are not sure things. But these are seriously negative trends, and I have read reports by economists that say if we get to 4 degrees, economies of the world really won't be surviving, because the fundamentals that they rely on, water, the ability to transport things, a stable infrastructure, will be so damaged that we'll have to reinvent the economy of the world. And when you get into 5 degrees and 6 degrees, it gets really hard to even find any confidence levels that are very high in the IPCC assessments, because we haven't seen this kind of change happen this quickly, ever. But the estimate is 40 to 70% of species are extinct, global GDP is dropping, food production declines, probably by quite a lot. This is pretty serious stuff. And if you look for estimates of what happens at 6 degrees, the only one I could find was a reconfiguration of the coastline, which is sort of a no-brainer, right? And along the way, there are tipping points. There are do you know what a tipping point is? Tipping point is like, it's a great analogy. When you lean back on 2 legs in a chair and you've got yourself balanced just right. Well, tiny input of balance will topple you over backwards, and once you start, you can't come back, right? Well, there are some tipping points that are thought to exist in natural systems, like the loss of polar ice. It gets to the point where it's not recoverable because it's too thin. It can't persist from year to year. The rainforests have died back severely. The northern forests died back severely. The monsoons that feed Asia collapse. Things like that. Fairly serious stuff. So, this is all important stuff to know because we have to decide what we're willing to live with, what we will tolerate, in order to sort of steer the elephant down the path we choose. And Bill talked about the rise in population. This is a graphic representation of it. It took about 95,000 years to reach 1 billion people, and that happened in about the year 1800. It took 130 years to reach a 2nd billion people. It took about 30 years to reach the 3rd billion people. Now we're adding people, what is it, Jerry? About every dozen years it's 1 billion more?
I think it's 14 years.
Every 14 years. The estimates are roughly 9 billion people by the middle of this century. California's population is supposed to rise by about 30 to 35%, something like that. So if you didn't like the 710 tonight, just wait. And most of the growth is in developing countries. So that's a factor. That's something we need to know about. And in those developing countries, anybody watched the Olympics knows that China is not a sleepy little place anymore, right? Their growth is astronomically fast. So that means their consumption of resources is astronomically fast. They have every aspiration of living the lifestyle we live, so do people all over the world. So that is part of what Bill was talking about at the end of his talk. Right? The world is changing. And we face a set of, as Bill said, a set of interlocking challenges. Food supplies are shrinking. Water supplies are shrinking. Water has been called the gold of the 21st century by some people. Our energy supplies are starting to shrink as demand is rising. As people begin to compete for resources or have to relocate, there are questions about security and all that kind of stuff. And in the midst of all this, climate change is not only a driver of a lot of this change, it's also an amplifier of a lot of pressures that are already on ecosystems in society. So this is the kind of stuff we have to unfortunately, think about. It's not what we want to think about, but it's part of the game. And this is a graph that Richard Somerville spent a lot of time on last night. It's a fascinating graph. It came from a guy named Meinshausen in the Potsdam Institute in Europe. And he has calculated the total amount of CO2 we can add to the atmosphere if we want to have a reasonable chance of keeping the world below 2 degrees of warming. Now, by reasonable chance, he's saying a 2/3 chance, 67% chance. Now, I'm not going to get on the freeway if I have a 67% odds of getting where I want to go. I mean, this is not like a sure thing. But it's about as good as we can calculate because of some of the uncertainties in the climate system. And there are 3 slopes here. And the whole idea of it is that the sooner we start reducing greenhouse gas emissions. That's the screen slope. If we let them peak next year, 2011, they can sort of ramp down gradually, and by the middle of this century, we can still be emitting some CO2 and have a 2/3 chance of staying below 2C. But if we delay a little longer to about 2015, and emissions peak then worldwide, and we have to decline more steeply, and before 2050, we have to stop emitting CO2 if we want a 2/3 chance of staying below. If we dither a little bit longer out to about 2020, we have to drop very precipitously. Richard calls this the bunny slope, the intermediate slope, and the double black diamond. Right? It gets a whole lot harder, and it's a way of showing something that scientists have been saying for a long time, which is that we're at the crux right now. We need to make some decisions right now about what we're going to do about this, because we are committing ourselves to a future every day we delay. And pretty soon, the idea of staying below 2 degrees will be out of reach, or we'll have only maybe a half chance of it, or a 1 in 4 chance of getting it. We will gradually slip away from us. So I'm going to add something to this graph, because I've done a lot of reading about what historically has been the way that we have seen change, innovation take place. Right? And some of the things that we talk about doing to reduce fossil fuel consumption are to replace our buildings with more energy efficient buildings like the one we're in tonight. Because our homes and buildings are not built to save energy, they were built to be cheap to build. And energy was always cheap, so they're horrendously wasteful of energy. We can change our vehicles, but it takes, on average, 15, 25 years for a new technology to penetrate the market enough to make a big difference, because cars last a long time. And we keep driving them, and it takes a long time for new vehicles to replace them. We can change our energy supply. Right now, renewable energy provides about 1% or so of our electric power, our energy in general. So we have a long way to go to ramp that up. That doesn't happen instantaneously. So if you this is a qualitative gradient kind of graph, right? The impact of new buildings on reducing our greenhouse footprint is going to take a while to be realized. We're not going to see it right away. Likewise, new vehicles will gradually have an impact. I'm driving a Prius. I'm seeing more and more Priuses, and we're seeing Nissan Leafs come to market, electric cars here in California. We have a long way to go to replace all the cars and trucks in the world with something that's cleaner. We can replace our energy supply, but that takes time to build, and it's being built very rapidly in California. Southern California Edison, which supplies more renewable energy to its customers than any other utility in the country, is providing something like 20% of its electricity from renewable sources, and they are committed to reaching 30% in the next 10 years. And it's a big, big job. It's not insignificant. But there's something else in here that never gets talked about very coherently, and that is energy efficiency. If our buildings and habits and cars are wasting energy by gobs, by large amounts, then theoretically we should be able to reduce our demand for energy by becoming more efficient essentially almost overnight. Right? This is the one thing we can do rapidly. And from a social change perspective, the great thing about harnessing everybody's energy to do that is that it creates a new culture. It creates a new awareness of priorities and new sort of unspoken expectations for how we live and what we expect from each other and how we behave. So a lot of the discussions about how to respond to climate change are policy and technology discussions. And there is a growing awareness that getting the public motivated, getting all of us motivated to be more energy efficient, can actually have a ripple effect. Not only will it help us reduce emissions quickly to a certain amount, but it will also create a new ethos in our society about energy efficiency, which will be helpful as well. Yeah.
Yeah. If it's getting the public motivated, how are you accounting for the fact that the voting in the last election on that proposition, that the California voters voted against the oil company? to maintain the climate change
Right.
changes here. What is different about our population than somewhere else?
Are you a shill? Because I'm going to talk about that later. I will answer that question kind of at the end. Everybody knows Proposition 23 was an effort by oil companies and libertarians to undermine California's climate law, right? And Californians, it turns out, have adopted the ethos that cleaning up our environment is good for us and that we can prosper and have a cleaner environment at the same time. And that's part of their answer. The other part of the answer is we love to hate oil companies. And so I'm going to show you a little bit about how that campaign was pitched to take those motivations and turn them on to the point that people overwhelmingly voted against Proposition 23. So this is sort of our lay of the land. So it doesn't do any good to do anything about it if we can't literally do anything about it, right? What are some of the barriers in our path? Well, a guy named John Krosnick, who is one of the people who does research into public attitudes about policies, has been studying climate change for a long time. And he says that every top national priority has 5 characteristics. You have to believe that the problem is real, or there's no point doing anything about it. You have to believe that it's caused by the things we do, because if it's natural, there's no point doing anything about it. We have to believe that the impacts of this thing are harmful to us in totality. The net effect is that it's harmful for us. Otherwise, there's no reason to do anything about it. You have to believe we can solve the problem. Otherwise, you're just rearranging the furniture on the Titanic, right? It doesn't matter. And lastly, you have to feel pretty certain that your views about this are correct. So, in his measurements, and this has been slip sliding lately, but the majority of Americans think climate change is real. That number has slid back recently. Believe that humans are causing it and the net effects are harmful. There's very, very low measures of people who believe that we can solve the problem, which is really an interesting thing. It means that we have done what all of us have been doing who communicate about this for a long time, which is telling everybody we have a horrendous problem. And we have done a lousy job of talking about what we can do to solve the problem. I mean, raise your hand if you've heard a compelling story about how we can actually bring climate change into some sort of meaningful, controllable way. You have?
Yes, I saw the graph that showed if we do 5 of these 10 things, and we have choices among them, and some will pay off sooner than others. And yeah,
Okay.
That's been explained clearly.
Okay. So I would submit that since nobody else raised their hand, we are sort of evidence of this fact. And the other thing is that people are not terribly certain even about the things that they think are true. And that's been the focal point of the disinformation campaign that has been attacking climate scientists with ClimateGate, attacking them with the IPCC report, trying to say it's riddled with flaws, when in fact there are a few minor points in it. I don't know if you know about this, but this is a long-standing campaign that's very well funded, partly by ExxonMobil, through a bunch of think tanks, and largely by the Koch brothers, Koch Industry, 2 very libertarian, anti-socialist, anti-regulatory, very wealthy oil men from Kansas. A couple of the richest people in the country. They founded, they're the people who put up the money for the Tea Party movement. They founded the Heartland Institute, the Cato Institute, and all of that. And their approach, their methodology has been to create doubt. Because as long as people don't become solidified in their understanding of this, it's very hard to raise climate change to a high priority for the nation. And right now it's languishing very, very far down the list. Another barrier. Do you think your own actions matter? The things you do. Bruce does. Bill does. Yes?
I definitely believe it. But sometimes I get discouraged because I think the rest of you are not doing the right thing.
There's a lot of sense that we're so small and the problem is so big, right?
This is the guy who said he had a muscle car.
I'm just trying to wake you up.
Well, I've heard
We're
this a
listening.
lot, you know, this is a problem that if I change one, you watched Al Gore's movie, how many people saw Al Gore's movie? A lot of people saw it. The thing that was most discouraging about that movie is he spent 99% of it telling us we have this terrible problem. He did a good job of it. And in the credits, it tried to tell you things you can do. Change a light bulb. Are you kidding? Really? That's it? You know, buy a Prius. Okay. How much difference does it make? Well, I decided to find out. Because I own a small company, I decided to find out. Why not? So I set it up as a real experiment. The conventional wisdom says the things we do don't matter. If you read, you know, we have this climate law in California, AB 32, which starts to take effect next year. And I read the scoping plan for it. And the whole idea is you get the electric utilities to change the way they do business. You get diesel truck companies to change the way they do business. Agriculture changes the way they do business. And then there's a caption about small businesses and households. And it says, you know, it's the households and small businesses in California that are really going to make this California's plan. I thought, well, this is going to get interesting. What do they want us to do? Well, we hope you'll do voluntary things. I thought, well, that's interesting. I wonder what resources they'll give us. We'll try to establish a website with a toolkit of good ideas. It's ridiculous. And I talked to the people who direct the California Air Board who work on this, and they said, homeowners and small businesses are too hard to manage. They're too scattered, they're too dispersed, they have different scenarios in their lives. We can't figure out how to do them. So the assumption is we're not part of it. This is somebody else's problem to solve, right? And since we're all small consumers, we're all small polluters, the focus is on the big polluters and the big consumers. The truth is there isn't very much empirical research about how much difference it makes for us to do anything. So I decided to become one data point. And I just want to show you something that startled the heck out of me. Because my business's story is that the things we do can make an absolutely huge difference. It can save us a lot of money and radically cut our emissions quickly. So we have this 2,000 square foot house that's used for business. It's got 10 employees in it. And we did some very simple things. We signed up to get our emissions measured. We set really challenging goals. I wanted to meet AB 32's goals within 10 years instead of within 40 years, because I don't buy big equipment, so I figured, why not? And we did some really incredibly boneheadedly simple things. I mean, nothing sexy, nothing challenging. I bought a Prius. And then I decided not to drive it, so we have a telecommuting program. We replaced a whole bunch of, our copier lease ran out. We had this big old copier, we could have bought it for $1. And I thought, well, we've got a bunch of laser printers, we've got scanners, we've got fax machines. Let's get rid of all of them and get one multifunction machine that does a better job of all of it. So we did that. We changed all of our light bulbs to contact fluorescence. Edison gave them to us. That was pretty cool. Our air conditioner broke down on an August day last year, a couple of years ago. That wasn't fun. And it cost about $3 grand to fix it, but we redid our ducts, so we spent a total of $7,000. So, I mean, these are not hard things, right? These are ridiculous things. Well, look at the results. This is our carbon footprint before we started was almost 19 metric tons. 2 years later, when we were finished, it was below 7 metric tons. That's a 2/3 cut just by doing that stuff. And I added up everything that was financially related to the changes that we made. And we're saving $9,000 every year. It cost $7,000 to do it, we're saving $9,000 every year. This is, now, we're winning awards. We won a national award, we won a state award, and I'm thinking, this is pathetic that we're winning awards for this. Really. A little company in a little house in California is winning a national award. That just tells me that nobody's doing anything, right? There are 29.6 small businesses in the United States. If you took these results, let's say you got results that were half that good, and you multiplied it by 30 million companies and 100 million households, that would make a significant change. It would probably cut the nation's emissions by, total guesswork here, what, 20% maybe? But it would get everybody involved in doing things differently, and that would change the marketplace, it would change the political landscape, it would change the way we think about how we live. It's huge. So that was all about clearing the path. Now we know it's possible to do, right? Had no idea it was possible to do. What are the big policy things? I just want to kind of, I don't know if you folks know about this stuff, so if you do, stop me, but you know, there's sort of three main policy issues, ways of dealing with climate change from a policy point of view. One is to regulate greenhouse gas emissions. EPA is doing that, right? You just make it illegal to emit a certain amount, and you taper that off over time, and it forces the marketplace to adjust. Second way is with financial incentives. We spend public money, which means we spend all of our collective money, to create incentives for things like renewable energy, energy efficiency, new technologies, technologies that will convert waste to concrete, things like that. The third is to create disincentives. Make it cost money to pollute, and ramp up that cost over time so that it becomes increasingly unpleasant to pollute, so you'll have an incentive to change, right? Well, you know what's happening if you pay attention to the news. There's a lot of angst about whether the EPA is going to be taken to court and be allowed to regulate. There are always questions about how much money to spend on incentives, public money. And so the favored approaches that get most of the attention are either a carbon tax or a cap and trade plan. And they are essentially two ways of trying to do this exactly the same thing, which is to take the true social cost of using fossil fuels, the cost of pollution, the cost of our health, the cost of military action to defend our ability to get these things, and make it part of the cost of using the fuels, right? And there are two ways to do it, and politicians and economists argue about which is better and which is worse. The fundamental idea in all of it is that you want the cost to increase predictably over a long period of time. Because if I own a power plant, and I'm going to build a new one, the point at which it costs me more to pay for emitting than it would to build a new one is the day I'm going to build a new one, right? And since investors want to be able to look long-term at their investments, if you have an increasing cost for polluting, then it lets everybody figure out where their own best trade-off lies, and so that people will be encouraged, businesses will be encouraged to make the move when it's most to their greatest advantage. The difference is that if you create a tax, it's called a tax, some people don't like that. We already have a structure for taxation, so we don't have to create new bureaucracies for it. But it has to be managed predictably over a long period of time. It can't be bouncing up and down with every whim, or it becomes unpredictable. The more politically palatable approach apparently these days is cap and trade. And the idea is you set a maximum limit on pollution, and then you let people buy the permits at auction, and you reduce the number of permits every year over a long period. Presumably the cost of those permits rises, but you let the free market speculate on the price of them. So it's not a direct tax, but it in fact is in effect supposed to be a tax. It's proven to be very volatile in the experiments that are here. But California has just instituted a cap and trade scheme. It hasn't taken effect yet. There's another one in the New England states, and there's another one forming in the Midwest. So we're all about to learn how cap and trade works. But the fundamental idea is you make it costly to pollute so that there's a disincentive to pollute. So now the elephant. What motivates us over the long run to accept these kinds of things and stick with whatever we do? Bill wants cash. He's rubbing his fingers together. That's one way to do it. But there are other ways to do it, and this isn't really about a lot of that stuff. Some of it's about values. And I want to sort of walk you through some of the ethical arguments that underlie the political discussions, the legal discussions, the international relations discussions. And there are sort of three basic principles that keep coming up in discussions about climate change. The first is what's called the precautionary principle. And it basically says, if you think there's a possibility that what you're going to do is going to hurt somebody, you shouldn't do it. So when you apply that idea to climate change, the formulation is that even though you're not certain, 100% certain what's going to happen in the climate system, if the indicators are that it's dangerous, you shouldn't do it. Right? And so uncertainty is not a reason to delay.
The man in the street language for number 1, the precautionary principle, is the golden rule. And the Hippocratic oath, that you first do no harm, and you do to people what you would expect would reasonably be done to you.
Yeah, that's exactly right. And it pushes it even farther to say, not only should you not do harm, but if there's a good chance that what you're going to do is going to do harm, you shouldn't do that. Yeah.
Sort of sounds like a Judeo-Christian ethic.
Well, it is. That's where it comes from, but it's also international. The second, distributive justice principle, which sort of means if a lot of people are doing things that cause harm, then they're responsible for their portion of it, right? Which is a way of saying, if you're Bangladesh and you're not emitting much CO2, you're not contributing very much to this harm. It's not really so much your problem to solve. If you are one of the world's 2 biggest emitters, you're causing a lot of harm. You therefore bear a bigger portion of the responsibility for dealing with it. The third is historical responsibility. It basically says whoever has been benefiting for a long time from something that's causing harm to others is responsible for remediating that harm. And that's a claim that's being made by developing countries against the United States and the first world right now, right? We've been living high on the hog. How can we tell the developing world that they can't have aspirations for our lifestyle when we've been enjoying it? We're responsible for dealing with the problem. So I thought you might be interested in knowing this because this is really what's happening in the Copenhagen negotiation and the negotiation that's upcoming in Cancun in November to try to create an international treaty about this stuff. It's what fundamentally was at the base of the Kyoto Protocol negotiations that were so contentious. A couple of other points to note. There's an ethicist I've been working with at the University of Washington who points out when he gets into arguments with economists all the time, economists are talking about carbon taxes and cap and trade, and he said that's only one way to look at this problem. And the unfortunate thing about economic models is they look at the economy as a whole. They can't look at the question of who's bearing the burdens, fairly or unfairly. And we already know that people who have the fewest resources, people who live in disadvantaged communities and are poor, tend to bear the burden more than anybody else of the harms of things like climate change. When it's hot, and if you live in South Central LA and there's no air conditioning and you're in a really intense urban environment, you're having a worse time than somebody who's living in Palos Verdes up on the hill with a swimming pool, right? It's kind of as simple as that. So the question is, how can the disadvantaged be protected, and how do we share? There's a huge, there's actually a great analysis written by an economist from England named Nicholas Stern, and he said he looked at how much each person in the world emits, right? And you know, we're all emitting here 7 or 8 times more than the average Chinese person. If they're going to increase their emissions, maybe double it, so they're 2 times more than they are, in order to compensate for that, we'd have to reduce our emissions dramatically, right? In order to come in any sort of equitable balance, and that's really a big challenge. Other arguments that are happening on the international policy stage. Who has the historical responsibility? The catchphrase for that is the polluter pays. So if BP pours a bunch of oil into the Gulf, it's BP's responsibility to clean it up. We sort of take that for granted, right? So the rest of the world looks at the United States and says, well, if you've been pouring carbon into the air for 150 years, guess who needs to clean it up? Who has the capacity to act? This is a sort of a fundamental question that in the moral philosophy world and in the legal world. If you don't have the capacity to do anything about something, you really shouldn't necessarily bear the burden. If you have the deep pockets, the burden always falls to you, right? Does everyone have an equal right to emit carbon?
Of course.
It's sometimes called, do we all have the right to a subsistence level of carbon? And if the answer is yes, and we agree that the total sum of our emissions is dangerous, then does that mean we have to give up our luxury emissions in order to make room for people's subsistence emissions? It's a tough question, huh? Luxury emissions would be defined as going on vacation, living the lifestyle we live, dressing in fine clothes, going out for an evening in a beautiful aquarium to have a lecture to learn that you shouldn't be doing this, all that kind of stuff, because other people are dealing with basic sustenance issues. Right? Should decisions be made to benefit the most vulnerable more than anyone else? Or, the counter argument is the last question, should decisions be made to maintain wealth? This is a fundamental argument in politics all the time. And it's a question of worldview. There is no right answer. Some people argue that it's possible to raise the total level of wealth all the time. So you never want to reduce the wealth of those who are doing well. You want to bring up the wealth of those who are doing poorly. And they believe it's possible. Other people believe that's not fundamentally possible. That you have to take something, the haves have to give something to the have-nots in order to balance things out.
So wouldn't brands be well benefit the world or more so than the humans?
Well, if we all agree that we need to benefit the earth, now we're fighting over who has to bear the burden most and who doesn't have to bear the burden most. That's really, I mean, if all the nations of the world had essentially said 2 degrees should be our limit, but we are haggling incessantly over how we go about getting there. And, nobody wants to blink first. It's almost like everybody's playing a game of chicken or a tough negotiation. There are people who think we should have regulation. It's as simple as that. There are people who say government should have its hands off the economy and free market will solve all these problems for us. These are really arguments about how you allocate the resources we have and what do we mean when we say it's fair.
If you generalize these things, it's like the eternal questions of human history, It's like, for the first time in the last 4,000 years, we're actually going to find answers to these questions.
We may. If you go back to some of these things, like the precautionary principle is a fundamental principle of international law. You're not supposed to do something that has potential to harm others. The polluter pays is a fundamental aspect of international law. I mean, we've enforced it, we've signed on to it, but we don't want to have it applied to us either. So, these are eternal questions, and they are constantly judgment balance questions. They're not like science in a sense. I mean, these are not about facts. This is about how we deal with the facts that are before us.
It's morality.
Yeah, it is.
Yeah.
And a lot of what morality is really about is how we structure our society and what we consider the right way to live with each other, right? That's what law is about. That's what policy is about. That's what social conventions are about. A lot of the things, it's what kind of a society that we live in. There is one aspect of, we were talking about communications earlier, and so the first thing I showed you with those thermometers is a way to deal with complex information that you have to think about. And it was a way to simplify a lot of graphic stuff in order to make certain insights pop out very easily, right? So that's one aspect of creating a campaign that helps people, is you help simplify things in a way that makes the things that are most useful to them pop out. But there's another aspect of communication that speaks to the heart, and it's branding. It's called branding. Everything's a verb now. Brand positioning is what we used to call it. And think about what brands are carefully. They are appeals that link products or services or companies or ideas to values that we hold very deeply, that have nothing to do with the item itself. It's not about what the thing does as an object. It's not about how much money it saves you. It's about values that we care about that we can associate with it. And I'll show you some examples. And the reason brands are popular among advertisers and political campaigners and others is because they're sort of sticky. When you can establish the meaning of a brand, it sticks with us and we become loyal to it. So here's an example. Oh, and they live inside our minds. That's the last thing. The people who think they own brands, don't. Just ask Coca-Cola how much it costs to change the formula, right? Sales plummeted, $500 million later, they've established Coke Classic and they're riding on the top again. It was either the biggest blunder of all time, or it was a stroke of marketing genius that just cost $500 million. Because what it showed is they don't own the Coca-Cola brand, the real thing. The idea that it's the real thing lives in the customer's minds and hearts, right? And so if you're the owner of the company and you mess with the meaning of that brand, it's like cheating on your girlfriend. You know, there are repercussions. Go with that. So here's a brand.
Only if you get caught.
What is this? What's that? And getting
Only
caught.
if you get caught.
They got caught. So, anybody want to take a shot at what values this particular brand stands for?
The Olympics.
It's the Olympics.
Excellence. Competition, fair play, excellence.
Fair play,
Well, it's
excellence.
supposed to be fair play.
Coca-Cola, Doritos.
I'm sorry. World friendship. International fellowship. Setting our differences aside to treat each other honorably and fairly. What happened when the Salt Lake City Organizing Committee bribed the Olympic officials to put the Olympics in Salt Lake City? It was a nightmare for PR. If the Worldwide Wrestling Federation had bribed officials to put the Worldwide Wrestling Federation, SmackDown in Salt Lake City, would we have cared? We would have thought it made sense, right? So the cheating on the part of the organizers to get the games where they wanted them violates the values that we associate with a sporting event. It's a sporting event, right? But it means all these other things to us, or at least it used to. Brands can be tarnished. Here's another one. Anybody know what this logo is?
Chevrolet, a Corvette.
The Corvette. And what does it stand for?
It's hot, sexy, fast.
It certainly stands for this, right? It certainly stands for this.
There you go.
I would submit that Prince could not have gotten away with a song called Little Red Lumina. Little Red Prius. Are you a songwriter? Why couldn't he have done it? Because the Corvette lives in popular culture, right? It's a brand that lives in all the associations and feelings we have associated with it, pro and con, are part of popular culture. So you can say Little Red Corvette and it brings up a ton of meaning. You can say Pink Cadillac and it brings a ton of meaning. That doesn't mean, this means that Chevy actually has a brand on its hands in the Corvette. The Lumina is not a brand, it's a name. And it's one of the biggest mistakes marketers make all the time. I think every one of their products is a brand. Only the ones that live in the hearts and minds of the public are brands. How about this one? Hi, I'm a Mac. And I'm a PC, right? How many of you have been in an argument over which one's better? You get into them all the time. You stumble into them by mistake all the time. For quarter after quarter before Steve Jobs came back to Apple, they were losing $100 million a quarter, $60 million a quarter. They shouldn't have existed. And yet, they were the basis of 3 international trade shows every year. There were 4 magazines devoted to nothing but Macintosh. And the world's most fiercely loyal customer base. You can imagine what was going on. I would argue that it's this little bite. It's not the apple, it's the bite. Who took the bite?
Eve.
And Eve. And what happened?
Taken out of the forest.
Yes, now this is where
The environment went downhill from there.
the environment went down. This is where PC and Apple aficionados part ways. To the PC crowd, we got thrown out of Eden. Bums. Right? Get with the program. We got more applications. Everybody uses it. Just get on board. To the Mac crowd, we gained the power to differentiate good from evil. We became independent, creative, thinking people. We became ourselves. We can make the world what we want. I can make photo album in 4 clicks, right? Don't shove me into that box. I'm going to be who I want to be, right? And when you listen to these arguments are about, gee, you know, I think you're right. I think I will get a Droid phone instead of an iPhone. It's about vanquishing the other side. It's like a jihad, right? And it's because it's wrapped up in our identity. It's what it means that much to us, and it will drive people to spend money different ways, to go out of their way to live different ways. They have different expectations of their friends. They have a different self-image about it. I would argue that those of us who were supposed to be doing climate communication haven't even thought about this effectively. There is no real brand for climate change, and it's being tossed around in the public sphere. Is it really a crock? Is it really a conspiracy? Is it really the end of the world? Is it really something we can solve? Is it really something I should care about? Is it really the most important thing in my life? We don't know. Nobody's done this job very effectively. And if we're going to do it effectively, this is one of the things people misunderstand about brands. If you don't get the rider and the elephant going in the same direction when you're trying to establish a brand, it will never take off. So if Apple didn't deliver on things that were easy to use and felt creative and looked gorgeous, then all this marketing would mean nothing, right? It would just, people, right before Steve Jobs came back in System 10, people were starting to wonder if having a Mac was really worth it anymore. So you really have to align the head. We have to really deal with what the science is telling us about climate change, what our actual realistic prospects are for adapting and mitigating it, what it's going to cost us, and our decisions about what we're willing to pay and what we're willing to live with as a trade-off. We have to align that with a sense of a worldview and a meaning of life that would keep us motivated. And you know, there's a lot of evidence that Americans are looking for a challenge. You know, there's sort of a, and part of this is my own hunch, but I see it in some of the social science literature, that people are asking to have their lives mean something. I mean, how did Obama get 75,000 people at rallies? He stood for something in their minds. I mean, this is part of his problem now, is he looks like he's not delivering on everything people invested in the image of him. It wasn't really him, it's the image of him, right, the brand. So it sort of suggests to me that we are ripe for the picking if we can figure out how to plant the right seed. And the one thing that sort of separates, I was talking to some of the social scientists who study climate change, and we're kicking around. You know, I sort of asked them, how do you deal with your emotional roller coaster? I mean, there are days when it's just like, holy cow, the world's coming to an end. This is just horrible news. And other days I feel really energetic. He said, yeah, it's like you become bipolar, you know, to deal with it. And I've become less bipolar over time. And I think what keeps me going is partly sort of an inherent competitiveness of just not willing to concede. But the other is that I have a hunch that we are capable of changing much, much faster than we generally give ourselves credit for. I mean, after all, when America finally got involved in World War II, we changed our industrial economy within 6-9 months, a year. You know, we stopped building cars and started building weapons. Women flooded the workplace for the first time, permanently changed the relationship between the genders. We're still working it out, but it turned a corner that we can't go back, right? We're capable of huge changes. We don't know if we're capable of a change this big, this fast, but we don't know that we can. But nobody's tripped that switch, and that's kind of the challenge. There have been some skirmishes about it. Remember, you probably have all seen this from the last election. This was the poster, basically, for the No on 23 campaign. And in a way, it was easy. But I talked to the people. I ended up being a spokesman for this campaign. I even got on Fox News once. That was kind of bizarre. But they did a lot of polling and a lot of studying, and they found out that, on the one hand, Californians really do believe in clean energy, in a clean clean energy future. There is the beginning of a brand there. We believe in cleaning up our environment. We've lived with LA smog. We know how bad it is. And we don't want to have somebody else putting on us. The other factor in this is that kind of gets glossed over is that people fundamentally, and we have a deep sense of rejection of those who try to cheat us, right? If somebody tries to pull the wool over our eyes, we don't like it much. And so all they really had to say was this: 97% of the money comes from oil companies, 90% of it comes from out of state, 75% of it comes from 3 oil companies. 2/3 of the voters rejected it. These are combinations of facts and emotional appeal that build stories, that build a sense of brand around this. Now, the great hope in the California Air Resources Board and in the clean energy community is that this sense of that these same kinds of motivations will transfer over to AB 32, the laws that are starting to come into effect now that are that Proposition 23 was designed to kill. And they're not trivial. This is the first law in the nation that commits us to any sort of pathway that is based on any sort of scientific assessment of what getting to staying below 2 degrees might look like. And it says we have to reduce emissions statewide to 1990 levels in the next 10 years. That means 15% below where they are today, and about 30% below where they would be if we just carried on without doing anything. So that's already a significant step in 10 years. And it means we have to drop them to 80% below 1990 levels by the middle of the century. In other words, almost eliminate greenhouse gas emissions in California in the next 40 years. Now, in my mind, this goes back to the whole question of the ski slopes thing, and I showed you it takes a long time for vehicles to change our emissions, and a long time for buildings, and a long time for energy supply. But we can reduce our wasted emissions, our inefficient energy emissions, within a couple of years. And it seems to me that the best pathway to reach the 2020 goal is an all-out campaign for energy efficiency in California. That means we shade our windows, it means we insulate our homes, it means we upgrade our air conditioners that are old, upgrade all of our appliances to Energy Star. We have one appliance that does our work instead of 4. We plug everything into power strips and turn them off when we're not using it, so we're not wasting vampire power. We stack our trips when we go driving so that we don't make 5 trips to the store when the engine's cold. You do it all at once when the car's running more efficiently. When it's time to replace your car, you buy the most energy efficient car you can. I mean, this is just a long litany of things, but they all based on one single fundamental principle, which is use as little energy as you possibly can to live the life you want to live. Simple principle. Use as little energy as possible to live the life you want to live. And if we do that, I don't think 2020 is a very hard target. I mean, that's been the experience with our company. Now, it doesn't translate equally everywhere, but that's kind of the gist. So, the last slide is the structure of this, and that book is called Switch. If you want to cut down some trees and read, or buy a Kindle and waste some electrons, by Heath and Heath. The rider, reason. The elephant, emotion. That's what keeps you going without wearing you out when willpower fails. And making changes in our environment we live in that allow us to do the things we want to do. If you want mass transit, we have to invest in it. If we want bike paths through town, we have to build them. All that kind of stuff, so that these things become options for us. I guess, just hearing the tone of my voice, that I am somewhat more optimistic than Bill.
Oh, I'm very optimistic. Personally, I just don't know about the rest of you.
All right, well, thank you.
Tom, before we... Really great talk, by both of you guys. The other concept that I thought was very interesting in that book is the one of connect the bright spots. And we don't do that. If we have to celebrate small victories, And whether it's in battling climate change or better interpersonal relationships with a spouse or a family, connecting the bright spots, and it makes the path much easier to make something happen.
Yeah, they also say it's very important to reward and acknowledge the small steps you make along the way. You know, you may not be anywhere near your goal yet, but you can feel yourself improving. I do a lot of athletic training, and you lift weights, you know, and it's really hard one day. You come back 2 weeks later, it's easier. That's important. It keeps you going.
The one thing I think you experienced, and we did here at the Aquarium, though, when we decided we wanted to green this institution, we went to the city, and instead of the city saying, we'll help you, we'll clear the path for you.
Yeah.
It was like an obstacle course, and that is really discouraging. They threw every roadblock in the way. Did you have some of that same?
Well, we didn't. I mean, we weren't putting in water urinals. We don't have unions to deal with. We didn't have, and we're in Signal Hill, which doesn't really have as many rules as Long Beach. They're not so onerous as Long Beach. But we ended up doing things that weren't going to require much between us and the city either. And it was, in some ways, it was luck. In some ways, it was just, I mean, some of it's just the way it happened. But I've read lots of stories about people who want to go solar, and they find that there's a huge permitting fee for solar that makes it ridiculous. You know, we ought to be encouraging this stuff rather than blocking the path. Yeah.
We'll take about 2, and then we're going to adjourn. Let's see, Teresa, and then Bruce, you've already had one, but we'll give you a second one because you're a nice guy. Go ahead, Teresa.
So I was thinking about the concept of branding when you're in your discussion. You talk about kind of environmentalism, and sometimes what hurts environmentalism is that people think it's just people on the extreme left, or it's kind of like a marginal part of the community. And what I think about, like with greening, like becoming green and being green, it seems more mainstream, but yet sometimes I still think like it's kind of like they'll be green, but it's not mainstream.
Yeah.
So have you thought through how we might brand green to make it more mainstream so that it's sticky?
I've actually been kind of involved in a piece of it, and I discovered it in the No on 23 campaign. The No on 23 campaign folks were very clear that they didn't want me to say green jobs and green energy. They wanted me to say clean energy jobs because it resonated very differently. There's this knee-jerk separation in our minds between business and environment. And when you say green, it reminds people of that difference. And so they loved me because I owned a business and I had greened it. So they would say, would you go talk to business groups? Would you go talk to other people? Because you have the kind of credibility that gets them to listen. And then some of it was choosing words. And it was clean energy, clean technology, cleaner future, rather than green. And that's the beginning. I think that's just sort of the first step in seeing what's going to catch on.
Choosing words, last night after the lecture, somebody was talking about George Lakoff. You should read one of George Lakoff's books. He's a linguist, and how you frame an issue, not political spin, but how you frame an issue. And he has a really good analysis of things. Bruce.
Let me just say before we go to Bruce, one of the other big discussions in climate strategy world, when I go to all these workshops where these things are being discussed, is how do you frame this issue? Do we want to make it primarily a national security issue? Do we make it an international competitiveness issue? Do we make it a pollution and public health issue? Do we make it an environmental issue? And it turns out the environmental frame is not very good. I mean, it doesn't resonate that well with people, but some combination of these other things, and I think that there is something about creating a national mission, a new national mission, sense of purpose that is sort of lurking under the surface and hasn't quite been tapped into yet.
Bruce.
The first answer I gave was about a UN report, and it takes about 10 minutes to understand it. There's a longer version of it, which is called Plan B, which has over 1,000 current citations. You say we're short on empirical evidence. And because this is international, it has 1,000 reports of what's happening here and there, the bright spots and so forth. You can read this on the internet page. You don't need to buy the book. The website is earthpolicy.org. It's written by the Earth Policy Institute, And it's the fourth version of Plan B. Plan A is more
That
of
makes
the
it
same.
Plan D? E?
B. Beta.
Beta.
And Bruce, that's a really good book. The people we need to reach aren't gonna read that book. It's
No,
guys like you
I
who don't have a life.
I
You said, read that book.
No, I didn't say you should read the book. I said that the abstract and the reference and the portal to it is earthpolicy.org. I didn't say read Plan B.
Bill, did you have a comment?
Yeah, I just have one question. Earlier on, you really couched it sort of as a morality issue when you came into how you implement it on an international level. And one of the things that I've always blogged on is that with the role that religion could potentially play in this whole thing, because it's a powerful, simple force
Yeah.
in the world, all right, that has, I think, really been untapped and uninvolved. Because I think, most people in the world can't read and write. So you're not going to be able to even see your talk.
There is a young but growing movement in the religious communities. I mean, you're starting to see books by theologians and others and congregationalists about how to deal with climate change and how to talk to your congregation about climate change. This is new. I mean, 5 years ago you didn't see it. So to me, that's interesting. It means that something different is starting to happen.
To me, it seems that if you can't get religion involved in the environment and the population issue, you're sunk.
And not just organized religions, but the whole spiritual community.
Yes, that's right.
It's got to be.
I don't know about that. I think it has to do with big money right now. Is what really is controlling that movement.
Controlling.
The movement of going green is for big money.
Oh, wow.
The big money is...
Big money as the big companies that are monopolizing the government and all those things. That's why we haven't really been able to go green. Because they want to
Well, I think so all the forces that keep us dependent on fossil fuels, the fact that we don't really feel like we have much choice, the fact that big oil and big money influences politics heavily, the fact that we have learned to live this way, we have to relearn a new way. These are all forces that we are talking about overcoming by creating change, right? And so part of that is how do you deal with political change, if that's the angle to take, but another part of it is how do you change the culture so that the political dynamic gets changed inevitably.
And one of the big issues that we've got to figure out how to use social networking, social marketing tools for environmental change. And we really haven't done that at all. But that's how.
Yeah, I think it always comes back. It's interesting because we, as designers, we get requests from our clients all the time. They want to start with let's use new technology. That's where they start. And I'm forever saying to them, fine, I don't have a problem with new technology, but that's just technology. What are you trying to say? Because it doesn't matter what technology you use if you get the message right. If you don't get the message right, you can use all the technology in the world and it will fall flat.
But if you get the message right,
Then
we have ways to communicate how we
Oh,
do
sure.
it.
Absolutely.
All right, this has been a really wonderful evening. Remember, there's no class next week. It's the following week, and it will be in the Honda Theater, and it's going to be the director of the Heart Institute, which is part of Texas A&M. He and his colleagues have been studying the Deepwater Horizon since the day after it blew, so I think you'll get a different picture. And then in the last session, we're going to try to put all this together and come to some conclusion. Great talk, Tom and Bill. Thank you.